Hello all, TechJax here. This video is going to be a video on basic EIGRP. This is in relation to the Cisco routing tree. I just finished up my CCNP route exam. It's been a couple of years since I got my CCNA, but I decided to go back into routing. So just want to go ahead and do a couple of demonstrations real quick since I'm fully ingrained in this again. I might as well go ahead and start trying to demonstrate some stuff in case some people out there are trying to get into networking. So I have GNS3 here, and I have a real simple topology here that we're going to set up in order to actually, configure EIGRP and actually ping interfaces and make sure that the protocol is working properly. We're going to talk a little bit about some of the basics and some of the basics in configuration as well. So the first thing first here, as you can see, we got 3 routers set up. We're going to go ahead and start those here in GNS3. And if you're going to do the CNA and the CCNP and all that stuff, I highly recommend getting GNS3. It allows you to run a Cisco IOS in full emulation so that you can actually do all of the commands and set up some really nice topographies and topologies, without having the limit of hardware. I have plenty of routers here, actually hardware routers, but this allows me to get into and out of topologies really fast and do configurations and like that. So we're going to go ahead and launch the console here, and then we're going to take a look at our router interfaces and go ahead and configure EIGRP and see what it's about. So let me go ahead and resize this window real quick. And over here, you can see I have that we're going to name these particular routers. So on router 1, we want to go ahead and name this router West. So we're going to go ahead and go into the global configuration mode. And you can do that with a config T. And here we're going to go ahead and do a host name. I'm going to name this West. And as you can see here, our router name changed to West. And I'm going to go ahead and do a show IP interface brief. And that lets us see what interfaces that we have at our disposal. So in order to actually configure this setup, we're going to have to make some serial connections between router 1 and router 2, as well as router 2 and router 3. And we're going to actually set up some LAN interfaces for the fast Ethernet interfaces. And we're going to go ahead and configure those as well. So the first thing we want to go ahead and do is go back into our global command and go into the interface command. So we're going to go ahead and do an interface, and we're going to go into our fast Ethernet 00. And we're going to go ahead and do IP address. And we're going to go ahead and configure this with the 172.16.20.1, 255.255.255.0. We're giving this a Class C address with 255 possible hosts, 1 for the subnet and 1 for the broadcast. So you're only going to have about 254 actual hosts that you can use. We just went ahead and configured that, and we got to do a no shut and actually get our interface up. As you can see right here on this line, our fast Ethernet interface is down administratively and by protocol. We're going to go and do a no shut, and we're going to bring this interface up. So now that this interface is up, we can go ahead and exit and go back into our interface and go into the serial interface. And we're going to go ahead and configure this with the IP address that we're going to use here. We're going to go ahead and use a class, we're going to go ahead and use a IP address in a subnet of /30 so that we have 2 hosts that can actually communicate on that subnet. So here we're going to go ahead and do IP address, and it's going to be 172.16.15.1, and the subnet mask is 255.255.255.252, and that allows us to have 2 hosts on that subnet that we can communicate with, as well as the broadcast and the subnet. So we're going to do a no shut there as well. We're going to end show IP interface brief, and as you can see, we have our interface is up. The serial interface is going to go back down because we don't have an active connection with it, and that's going to go back up once we actually configure it so it is connected to router 2. So we have our 2 subnets here, our 2 interfaces, they're up. What we need to go now to is router 2. We're going to go ahead and do the same commands. We're going to do config T, host name. We're going to go ahead and name this North. I'm going to end this, show IP interface brief so we can see what interfaces we got to work with. We're going to go ahead and configure our interface, a fast internet interface on this side. And we're going to set this up with 172.16.10.1, and this is going to be 255.255.255.0. No shut. Exit. We're going to go to the interface serial 00, and we're going to go ahead and set the corresponding IP address that we had on that subnet that was available. So that's going to be the 172.16.15.2 and 255.255.255.252, and no shut. So we went ahead to router 2 and we set up our interfaces here. So we have this fast Ethernet, it's up, it's running. We have our connection here. Now the only thing we have to do is actually go ahead and connect those with a link, because our serial interface should go back down because we don't actually have any connection between the routers. And as you can see, under the protocol, it's down. And just in case my head was in the way. So let's go ahead and add a link. We're going to serial interface 00 to 00 on router 2. And now we have an active connection between router 1 and router 2. Our interface just went up. It went up on both routers. And we should theoretically and in real life be able to ping the interface of each router. So I'm on router 2 now, so I'm going to go ahead and ping 172.16.15.1, and as you can see, we're getting a response. However, if I wanted to actually ping the interface on router 1 of 172.16.20.0, I'm not going to be able to, because we don't have any routing protocols. So the router doesn't know how to forward that packet in order to have it reach the destination. And we can't get a return. So that's why we're going to have to set up a routing protocol, and that's why routing protocols exist. So what we're going to go ahead and do is configure EIGRP. And EIGRP is a Cisco proprietary routing protocol, and if you guys are studying and all that, you should know plenty about EIGRP, especially when it comes to the basics. So let's go ahead and just configure it. And what we do here is we go to the global configuration. We're going to go into router EIGRP, and we got to give it an autonomous system number. So let's give it 2. And now that we're actually, we enabled EIGRP, but we didn't put in any network statements or any neighbor statements. So right now, it's not kicking out any hellos. But what I want to do is actually show you guys some of the things that happens when EIGRP is actually enabled. And you wouldn't do this in a production environment at all, but obviously in our testing environment, in our lab, we want to see what's going on behind the scenes. So on router 1, I'm going to go ahead and enable hellos. And I'm going to go ahead and configure EIGRP on router 1 as well. So that's router EIGRP2, autonomous system. So what I'm going to do is do a show IP interface brief, just so I can see what interfaces that we want to advertise. And we're going to go ahead and advertise the serial interface first. And that's going to be 172.16.15.0. And we're going to use 0.0.0.3 for that subnet. This is the wildcard. We're going to use the subnet equivalent that gets us the 4 hosts. And we're going to go ahead and hit enter. And as you can see, we're getting hello packets being sent now. So with EIGRP, any network statement that you configure on an interface on that router, it starts to send hello packets every 5 seconds. And the hold down time is 15 seconds when it comes to the hello packet. So the hello packet tries to establish with a neighbor, and then that neighbor has 15 seconds to respond or acknowledge those hello packets. And if it doesn't get a response, then that interface goes down, that adjacency is lost once that hold down timer expires. So every 5 seconds, it refreshes that hold down timer between routers so that they can stay in an adjacent mode. So our interface here is broadcasting hellos. And what we're going to go ahead and do real quick is I'm going to do a network statement for the other network, the 172.16.20.0. We're going to do a subnet mask that allows us to have the /24. And as you can see, that network as well is sending out hellos. We don't want that to be the case because that particular interface is not going to be connected to another EIGRP router, and it's not going to form an adjacency, and you don't want to have overhead on lines that you don't need. You don't want to have data and packets, going through lines that aren't going to, use those or not need them. So what we're going to do is we're going to go ahead and set the passive interface, and we're going to do this for the fast Ethernet 00. And this will stop the hello packets from being sent out on the fast Ethernet 00, because we only want the hello packets to be sent out of the interfaces that are actually going to be connected to other routers. So we do a show IP protocols. Okay. And I'm going to do a UART to stop the debugging real quick. And under show IP protocols, you can see that the routing protocol is EIGRP in Autonomous System 2. And here are the default EIGRP metrics, the K values. These must match between routers. If they don't match, an adjacency cannot form. The hold down timers, they don't have to match. When it comes to like the Ethernet segments and like the broadcast point-to-point, point-to-multi-point, hello packets are sent every 5 seconds. But if you're on a circuit that's slow, or slow WAN link, then it can actually go up to every 60 seconds. And the actual configurations of EIGRP and adjacencies, you got to have the authentication. If you want to use authentication between adjacencies, to protect your routing protocols, you want a secure routing protocol. You got to have the same authentication variables, obviously. You can't have one router have a different password than the other one and they form an adjacency. The K values have to match. The autonomous system number has to match. And you can't use secondary addresses, and the neighbors have to be in the common subnet. So if you're going to use /30 notation or /24, then it has to be that way on both routers for those routers to be able to communicate and form that adjacency. So here you can also see that under passive interface, my fast Ethernet /00 is passive. So under the show IP protocols, it allows you to see that the passive interfaces that have been enabled. In production environments where you might have an expansive list of interfaces, it's better to go into your routing configuration, and what you would do is set the passive interface to default. And if you set the passive interface to default, what happens is that all interfaces are in a passive interface, and then what you would do is actually enable or do the no passive interface on those interfaces that you want to have routers connect to. So let's go ahead and pop over to router 2 real quick, and we're going to go ahead and what we're going to do is advertise our network. Once I get into the proper command, and we're going to go ahead and do 172.16.15.0, 0.0.0.0.3 for the wildcard. And once we hit enter here, I have EIGRP package debugging on in verbose mode, so it's going to show us all the packets and that happens when an adjacency forms. We're going to be able to see all that, and I as well have the ability here. Once I pick that, we can go ahead and bring up Wireshark as well. And here in Wireshark, we're going to be able to see the hello messages being sent by the EIGRP protocol. And EIGRP, it sends its multicast messages out on that 224.0.0.10 using RTP, which allows it to be reliable when it comes to actually doing updates and queries and things like that. So we're going to go ahead and hit enter here and see what we get. Okay, then I'm going to hit you all to stop this because we got a whole bunch of information. And as you can see over here, we started to receive the hello messages, and we got some configuration information in here about what autonomous system number it was from, some of the parameters, the hold time, which is the 15 seconds. It lets us know the software version that we're using with EIGRP as well. So if you're using Wireshark, you can actually go ahead and look at the flags and a lot of things to actually, you know, get some more detailed information about what's happening, especially if you're going to have problems or you're setting flags, especially with different routing protocols and things like that. Here, you can see that right now this sent a unicast packet, because it sent it directly to the 172.16.15.1. It was a reply. And let's go ahead and pull this down real quick. And over here, under our debug, we get to see what started to happen. The EIGRP was turned on this router for that network. It started to be advertised, and we received hello messages from 172.16.15.1, which was this router over here, router 1. I should put .1 over there, right? .1. And this is .2. So once the K values and all that stuff, and they found out, you know, once the routers knew that there wasn't any authentication, instead it went down a list of parameters that had to be identical for each router, and then it formed the adjacency. And this was the process, in which case it sent an acknowledgement packet, it sent an update packet. So now we can go ahead and go to North and do a show IP route. And what we're able to see here is that we have two connected interfaces. One connected interface is the 16.10 network, which is that fast Ethernet, and it's alluded to here. We have the 172.16.15 connected, which is the serial interface, which is alluded to here. And now we have a subnet and the prefix that's learned via EIGRP, and that's labeled as D here. And that's the 172.16.20.0. And here we have the administrative distance. Eternally for EIGRP, it's 90. And we have the administrative distance that it takes to get to that. So over the serial interface is a lot slower. So you're going to have a lot higher value when it comes to the administrative distance if it has to go over such a slow link. But it's learning that from 172.16.15.1. And we should be able to go ahead and ping the interface now, and then we get a response. And if we do a show IP route on router 1, we don't see the 172.16.10.0 subnet because we didn't advertise it. So in order for me to fix that, I'll go back into our router EIGRP2, do a network 172.16.10.0.255, hit enter, and now we do a show IP route. Now we're learning about the EIGRP prefix via that network statement we just put in on router 2. So as you can see, we can go ahead and ping that interface now from router 1. And we're successful. So in terms of this topology, we're able to ping each interface on each router using the EIGRP routing protocol. So that was just a basic demonstration of setting up EIGRP. This was video 1. We're going to go ahead and do some more videos with this in order to actually, see how we can, configure summary, route summarization, and things like that. Do some filtering on some of the advertisements and things like that. So this is Tech Jacks. Thanks for watching.